Good afternoon. Today we will do exercise 4.1 of determinant. So we have already discussed how to find determinant of matrix order 1, order 2 cross 2 and order 3 cross 3. So the first question is evaluate the determinant of matrix 2 cross 2, 2, 4, minus 5 and minus 1. So just apply the formula of calculating the determinant of order 2 cross 2, that is product of diagonal element minus product of off diagonal element. Just calculate. So we have to find the value of determinant of matrix 2 cross 2, that is 2, 4, minus 5 and minus 1. So as we know, if a determinant whose entries is a11, a12, a21, a22, then determinant is given by just multiply its diagonal element, that is a11 into a22, then minus product of off diagonal element, that is a21 into a12. So given a is equal to 2, 4, minus 5 and minus 1, so we get value of a11 is 2, a22 is minus 1, a21 is 4, sorry, minus 5, and a12 is 4. So by using the formula, we get determinant of a is 2 into minus 1 minus 4 into minus 5, that is minus 2 plus 20. So required value of determinant is 18. Okay. Now, second question is we have to calculate the determinant of first matrices of order 2 cross 2, and its entries are cos theta minus sin theta and cos theta. Okay. And second one is it is also a matrix of order 2 cross 2 with entries x square minus x plus 1, x minus 1, x plus 1, x plus 1. Okay. So we have a matrix of order 2 cross 2, and we also know the how to calculate the determinant. Just multiply the product of the diagonal elements minus product of off diagonal element and calculate. So now we need to find the value determinant cos theta minus sin theta and cos theta. So on comparing with matrix A, that is A11, A12, A21, A22, we have the value of all the entries, and we know the determinant of matrix of order 2 cross 2 is determinant of A is A11 into A22 minus A21 into A12. So the determinant of matrix A is cos theta A11 into A22, that is again cos theta minus A21, and A21 entry is sin theta into A12, that is sin theta. So when we multiply, we get cos square theta plus sin square theta. We know by the trigonometric, the value of cos square theta plus sin square theta is 1. So determinant of matrix cos theta minus sin theta cos theta is 1. As when I explain you the definition of determinant, I determinant, I explain it as function. It take a matrix and map it with a number. So here a matrix is cos theta minus sin theta cos theta. So we take a matrix A from a set of all matrices, and the set of all matrices is a matrix of square matrix. Okay. And we take a matrix and then we map it with a number, and that number is 1. So determinant is a function which take a matrix and map it with a unique number. Okay. Now we need to find the determinant of x square minus x plus 1, x minus 1, x plus 1, x plus 1. Okay. So, and we know that determinant of A of order 2 cross 2 is A11 into A22 minus A21, A12. So, then we get determinant of A is x square minus x plus 1 into x plus 1. Entry A11 is x square minus x plus 1. And entry A22 is x plus 1 minus entry A21. A21 entry is x plus 1. And entry A12 is x minus 1. So we get x minus 1 into x plus 1. And when we expand it, so just multiply x square minus x plus 1 with x plus 1. We get x cube minus x square plus x square. And x minus 1 into x plus 1 is a minus b, a plus b, that is a square minus b square. So x square minus 1. As so we get x cube plus 1 minus x square plus 1. So the determinant of the matrix x square minus x plus 1, x minus 1, x plus 1, x plus 1 is x cube minus x square plus 2. Okay. So question number 3 is, we have given a matrix that is A is equal to 1, 2, 4, 2 of order 2 cross 2, and we have to calculate the determinant of it. Okay. And then so that determinant of 2A is equal to 4 into determinant of A. So in this case, at first we have to calculate the matrix 2A, and we know how we multiply a scalar with a matrix. Then at first find the value of 2A, then find its determinant. Okay. And for RHS part, at first calculate the determinant of A and then it multiply with 4. It says that both are equal. So just verify it. So we have to show determinant of matrix 2A is equal to 4 into determinant of A. Given matrix is A is equal to 1, 2, 4, 2. The sign of matrix is square bracket, and the sign of determinant is this mod sign, the vertical lines. Okay. So to calculate the determinant of 2A, at first we have to calculate the matrix 2A. And we know when we multiply a scalar with a matrix, the scalar is multiplied by the each element. So if a matrix is A11, A12, A21, A22, and we multiply with a scalar lambda, then lambda A is lambda A1, A11, lambda A12, lambda 21, and lambda 22. So we multiply each element with that scalar. So when we find the matrix 2A, we multiply 2 with each element. So we get matrix 2A as 2 into 1, that is 2, then 2 into 2, that is 4, 2 into 4, that is 8, and 2 into 2, that is 4. So matrix 2A is 2, 4, 8, 4. Now we have to calculate the determinant of 2, 4, 8, 4. Therefore, the part LHS, that is determinant of 2A, is multiply it, the diagonal element, that is 2 into 4, minus multiply the off diagonal element, that is 4 into 8. So 2 into 4 is 8 and 4 into 8 is 32. So 8 minus 32 is minus 24 is the determinant of the matrix 2A. Okay. So now we solve RHS part. So in RHS part there is 4 into determinant of A. So we have to calculate determinant of A. So determinant of A is the determinant of 1, 2, 4, 2 is multiply the diagonal element, that is 1 into 2, minus multiply the off diagonal element, that is 2 into 4. So it becomes 1 into 2 minus 2 into 4, that is 2 minus 8. Therefore, four into determinant of A, that is minus 6. 4 into minus 6 is minus 24. And we can clearly see that LHS is equal to RHS. Okay. Now, question number 4 is, we have given a matrix A, that is 1, 0, 1, 0, 1, 2, 0, 0, 4. Then so that the determinant of matrix 3A is equal to 27 into determinant of A. Okay. So, same as question number 2, at first we have to calculate the determinant 3A, and then we have to find the determinant of 3A. And for the RHS part, we have to calculate the determinant of A and then multiply with 27. And we have to check, is it equal or not? So try. Now, given matrix is A is equal to 1, 0, 1, 0, 1, 2, 0, 0, 4. We need to show the determinant of matrix 3A is equal to 27 into determinant of A. So it can be observed that in the first column, 2 entries are 0. Thus, we expand along the first column for easier calculation. So, as I already discussed that in theory part, if we to calculate determinant of order 3 cross 3, we have to calculate the determinant of 3 2 cross 2 matrices and then add it to get the determinant of matrix of order 3 cross 3. And for that, we take any row and any column and expand it along that row or column. Okay. And we take that matrix first and then multiply with the determinant matrix of order 2, determinant of matrix 2 cross 2. that we obtain by just cancelling the indices row and column. Okay. So we can observe in this matrix, in the first row, two entries are 0. So there is only present one non-zero entry, that is 1. So when we expand it along the first column, l- clearly the second and third part is 0, because we multiply with 0 to the determinant of any two cross 2 matrices. The value is 0. So it is easier to take that column or row in a such a way where minimum number of non-zero entries are present. Okay. So when we expand along that column, the first column, the first column is 1 0 0. So 1 into determinant of 1204, then minus 0 into determinant of 0104 plus 0 into determinant of 0112. Okay. So if we have to calculate a determinant of order 3 cross 3, when I recall the formula, so if we take the first element, that is 1, then multiply with the determinant of order 2 cross 2, that is obtained by just cancelling the first row and first column, because the indices for element 1, that is first element, is 1 1. So we have to cancel first row and first column. Then minus come from the minus 1 the power I plus j, and minus 1 the power I plus j. Indices for element the entry 0, that is entry 2 1. Okay. So the value of I is 2 and for j is 1. So 2 plus 1 is 3. So minus 1 the power 3 is minus 1. So we get minus here. Minus 0 into, as indices of 0 is 2 1. So just we cancel the second row, that is 0 1 2. Just see in the matrix. Uh, and imagine if we cancel the line 0 1 2 and the first column, that is 1 0 0, we only left with a matrix, that is 0 1 and 0 4. And for the third term, when we expand along the last element of that column, that is again 0, at first we multiply with minus 1 the power I plus j, and here the indices for that element 0 is I plus j, for that I is 1 and j is 3. So 1 plus 3, that is 4. So minus 1 the power 4 is again plus 1. So we get plus into 0, then multiply with determinant of order 2 cross 2, that is obtained by just cancel. Just see in the matrix, when we cancel the third row and first column, we only left with a matrix 0 1 1 2 of order 2 cross 2, and we have to find the value of determinant of that and multiply with the element 0. Okay. So that's how we find the determinant of a matrix of order 3 cross 3. And that's the reason we take column, if we take a column or row in which more number of 0 are present, because clearly we can see when we multiply 0 with that determinant, we don't even need to find the determinant of that matrix. As we know, when we get a number and when we multiply with 0, it already becomes 0. Okay. So we only need to find the determinant of matrix 1 2 0 4 and multiply with 1. Okay. And that's the reason we choose column 1 to expand. And if we see the matrix, we can also choose third row, because in the third row there is also 2 0. So we only need to find a determinant value, we only need to take 4, then 4 into the indices of 4 is 3 comma 3. The value of I is 3 and j is 3. So we just calculate minus I the power 3 plus 3, that is plus 1 into 4 into cancel the third row and third column, we get the matrix 1 0 0 1. So we only need to multiply 4 into that matrix. Understand? Okay. So determinant of A is 1 into 4 minus 0. And 4 minus, we apply the formula for determinant of 2 cross 2. Multiply the diagonal element, that is 4 into 2, and minus off diagonal element, that is 2 into 0. So 0. So determinant of A is 4. Okay. So to calculate the RHS part, we just multiply 27 into A. We get 27 into 4, that is 108. That is your RHS part. Now we calculate the LHS part. So to calculate the LHS part, we have to find the value of 3A. 3 into matrix A. And we know when we multiply a scalar with a matrix, we have to multiply each entry of the matrix with that scalar. So here scalar is 3. So when we multiply with matrix, we get 3 into 1, that is 3. 3 into 0, that is 0. 3 into 1, that is 3. 3 into 0, again 0. 3 into 1 is 3. 3 into 2 is 6. 3 into 0 is 0. 3 into 0 is 0. And 3 into 4 is 12. So now we have a matrix 3A, that is 3, 0, 3, 0, 3, 6, 0, 0, 12. Okay. So now we have to find the value of this matrix, the determinant value of this matrix. Okay. So to calculate the determinant, at first we have to choose along which row or column we have to expand it, so that my calculation is easier. So we can see in the first column there is 2 0. Also in the second column there is 2 0. So we can expand along first column, second column, and also third row, so that we can easily calculate the determinant. So without loss of generality, just take the first column. Okay. So the indices for element 3 is, the first element is 1 1. So minus 1 the power 1 plus 1, that is plus 1. So we get 3 into, cancel the first column and second and first row. So when we cancel the first column and second row, we get 3 6 0 12 minus 0. For the second element, we just cancel the second row and first column. We get the matrix 0 3 0 12 plus 0. We get 0 3 3 6. Okay. So we don't need to calculate second and third part. For the first part, 3 into determinant of 3 6 0 12, and the determinant of 2 cross 2 is product of diagonal element minus product of off diagonal element. So 3 into 12, that is 36, minus 0. So 3 into 36 is 108. And clearly from equation 1 and 2, we can see the determinant of 27 into determinant of A is 108, and determinant of 3A is also 108. Hence, determinant of 3A is equal to 27 into determinant of A. If we observe the question number 3 and question number 4, in general, the determinant of here the determinant of 3A is equal to 27 into determinant of A, and 27 is 3 to the power 3. So, and where the 3 is order of the matrix. Okay. And in the question number 3, determinant of 2A is 4 into determinant of A. That is, determinant of 2A is equal to the power 2 into A. And here 2 is order of that matrix. So whenever we have to calculate determinant of Ka, where K is any scalar, and then we don't need to first multiply the K with all the entries of that matrix to get that matrix 3 Ka, and then find determinant. We just calculate determinant of A and multiply it with K the power order of that matrix. Okay, let's suppose the order is n, then determinant of Ka is equal to K the power n determinant of A. That is a general observation. Okay. So next question is, evaluate the determinant of matrix 3 minus 1 minus 2 0 0 minus 1 3 minus 5 0. Matrix, this is order 3 cross 3. Second question is, it is also of order 3 cross 3. 3 minus 4 5 1 1 minus 2 2 3 1 0 1 2 minus 1 0 minus 3 minus 2 0 0. So here there is 4 matrix of order 3 cross 3, and for all we have to calculate the determinant. Okay, try. Okay, so let's do first question. So part A, we have to calculate the determinant of matrix of order 3 cross 3, whose entries are 3 minus 1 minus 2 0 0 minus 1 3 minus 5 0. So we need to find determinant of given matrix. And when we observe clearly the matrix, in the second row, the two entries are 0. First, the entry is A21 and 0, the entry is A22. Okay. As we know, the it's A22 represent second row and second column. Okay. So as there are two entries are 0 in the second row, so we expand along the second row for easier calculation. Then we get determinant of A is equal to minus 0 into here. At first we multiply 0 with minus. Why? Because the indices of the element 0 is 2 1. And when we calculate minus 1 the power 2 plus 1, that is minus 1 the power 3, and that is minus 1. So we multiply 0 with minus. As we don't need to calculate this, but still, we multiply with minus 0, then into determinant of matrix minus 1, minus 2, minus 5, 0. And how we get this? Just cancel, as indices of 0 is 2, 1. So cancel second row and first column. So when you show in the matrix A, when we cancel second and first column, second row and first column, we get a matrix minus 1, minus 2, minus 5 and 0. Plus, why plus? Because indices of 0 is 2, 2, and minus 1 the power 2 plus 2 is 4, and that is even. So it become plus 1, so it is positive, into 0 into, when we cancel second row and second column, we get a matrix 3 minus 2 3 0. Okay, then minus the third element is minus, minus 1. We get minus because indices is 2, 3. And minus 1 the power 2 plus 3, that is 5, that is odd. So minus 1 the power 5 is minus. So we get minus into minus 1 into determinant. When we determinant of matrix 3 minus 1, 3 minus 5. And we obtain this by cancelling third column and second row. Okay. So to calculate determinant, we apply the formula for calculating determinant of order 2 cross 2. Just multiply. Minus into minus 1 is plus 1. 3 into minus 5, product of diagonal element, that is minus 15. Minus product of off diagonal element, that is minus into 3, that is minus 3 minus 1 is plus, and minus 15 plus 3. So it becomes minus 12. Determinant of matrix A. Okay. Now, question 2 is, there is a given a matrix of 3 cross 3. So evaluate determinant. Given matrix is 3 minus 4, 5, 1, 1 minus 2, 2, 3, 1. So we need to find determinant of given matrix. So here there is no zero entry. So we can expand with along any row and any column. So by expanding along the first row, we have first element of first row is 3 and indices of 3 is 1, 1. So minus 1 the power 1 plus 1, that is positive, and so 3 into determinant of matrix of order 2 cross 2, that is obtained by cancelling first row and first column. So we get from matrix 1 minus 2 3 1. Then minus why minus? Because indices of 4 is minus 4 is 1 2 and 1 plus 2 is 3, that is odd. So minus 1 the power odd is minus, so we get minus here. So minus into minus 4 into, just cancel the second column and first row, we get a matrix 1 2 1 minus 2 2 1. Okay, and for the third element of that first row, we get plus 5. Plus, because indices of 5 is 1 3 and 1 plus 3 is 4, and that is even. So we get plus 5 into determinant of 1 1 2 3, and that is obtained by cancelling third column and first row. So apply the formula for determinant of calculating second order matrix. We get 3 into 1 into 1 minus 2 into 3 plus minus minus plus 4. Then diagonal element 1 into 1 minus 2 into 2 plus 5, 1 into 3 minus 1 into 2. So determinant of A is 3 into 1 plus 6 plus 4 into 1 plus 5, 1 plus 4 plus 5 into 3 minus 2. So we get 3 into 7 plus 4 into 5 plus 5 into 1, that is 21 plus 20 plus 5. So determinant of A is 46. Okay. So third matrix is order 3 cross 3, that is 0 1 2 minus 1 0 minus 3 minus 2 3 0. So just think how to calculate this determinant, and we should take which column and which row to expand. So given matrix is 0, 1, 2, minus 1, 0, minus 3, minus 2, 3, 0. So we need to find determinant of given matrix. So by expanding along the first row, we get 0 into determinant of cancelling first row and first column. We get 0, minus 3, 3, 0. Minus into cancel the first row and second column. We get a matrix minus 1, minus 3, minus 2, 0. Plus third element, that is 2. Its indices is 1, 3. So minus 1 to the power 1 plus 3 is plus. And cancel the first row and last column. We get minus 1, 0, minus 2, 3. So to get determinant of 2 cross 2, that we need to multiply with that element, just cancel the row and column in which that element is present. Okay. So we can observe here 2 is present in first row and third column. So to get the matrix of order 2 cross 2, for which we have to find the determinant and multiply with 2, just cancel the row and column in which 2 is itself present. So 2 is present in first row and last column. So just cancel it and we get the determinant minus matrix minus 1, 0, minus 2, 3. Okay. So 0 into that determinant is 0. Then minus 1 into calculate is determinant, that is minus 1 into 0. Product of diagonal element, that is 0. The product of off diagonal element, that is minus 1, minus 3 into minus 2, that is 6. So minus 6 plus 2 into 3 into minus 1, that is minus 3. And 0 into minus 2 is 0. So we get determinant of A is minus 1 into minus 6 plus 2 into minus 3. That is 6 in minus 6. So determinant of A is 0. Okay. Now we have a matrix 2 minus 1 minus 2, 0 2 minus 1, 3 minus 5, 0. So calculate. So given matrix is 2 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. We need to find determinant of given matrix. So in this matrix, only only two zeros are present in the first column and last column, as in second row and third row. So we can expand along first column, last column, and second row and third row. So just expand along first column. Okay. So the element of first column is 2. The first element, second element is 0. And third element is 3. And indices of 2 is 1, 1, 4, 0. It is second row and first column. So 2, 1. And for 3, it is third row and first column. So it is 3, 1. I present row and J present column. So we get, now we have to see the sign for 2, 0 and 3. And for 2 is minus 1 the power I plus J, that is 1 plus 1. So 2, it is even. So the sign for 2 is plus. For 0, it is 2, 1. That is 2 plus 1 is 3. That is the odd. So minus 1 the power odd is minus. So the sign for 0 is minus. And sign for the entry 3. And for the indices for 3 is 3, 1. That is 3 plus 1, that is 4. So it is even. So minus 1 the power even is plus. Okay. Then so we get 2 into determinant of 2 is present in first row and first column. So just cancel the first row and second column, first column. We get a matrix 2 minus 1 minus 5, 0. For the element 0, it is present in first row second row and first column. So just cancel second row and first column. We get a matrix -1, -2, -5, and 0. Plus 3. 3 is present in third row and first column. So cancel third row and first column. We get a matrix -1, -2, 2, and -1. So we get 2 into, to get a determinant of order 2 cross 2, multiply diagonal element, that is 2 into 0 is 0, minus off diagonal element, that is -1 into -5, that is 5. So we get 0 minus 5 minus 0 plus 3 into product of -1 is 1. 2 into -2 is -4. So minus minus plus. So it becomes 1 plus 4. So determinant of A is -10 plus 15. Hence, determinant of A is 5. Okay. So question number 6 is same question as previous. We have given a matrix of order 3 cross 3. Find determinant of A. So just calculate. So given matrix is 1 1 minus 2, 2 1 minus 3, 5 4 minus 9. Now we need to find determinant of given matrix. So by expanding along the first row, as if there is no zero entry, so we can expand along any row and column. So just expand along the first row. We have first element is 1 and indices for 1 is 1 1. So sign for 1 is -1 the power 1 plus 1, that is positive. So it 1. For the second, it minus, and for third, plus. Okay. So we get 1 into 1 present in first row and for first column. Just cancel it. We get a matrix 1 minus 3 4 minus 9. For the second element -1, we get a matrix 2 minus 3 5 minus 9 by cancelling the first column and first row and second column. Okay. For -2 is present in first row and third column. So just cancel it. We get a matrix 2 1 5 4. So calculate a determinant of all these three 2 cross 2 matrix and multiply with that element. We get 1 into -9 plus 12, -1 into -18 plus 15, -2 into 8 minus 5. So we get 1 into 3 minus 1 into -3 minus 2 into 3. So it A is equal to 3 plus 3 minus 6, 6 minus 6. Thus, determinant of A is 0. Okay. Now, question number 7 is, we have to find the value of X if determinant of matrix of order 2 cross 2, 2 4 5 1 is equal to 2x 4 6 x. Okay. And second one is, if determinant of matrix 2 3 4 5 is equal to determinant of matrix 3x 3 2x 5. So we have to find the value of X. And to get the value of X, just calculate the determinant of both matrix and we get an equation. And when we solve that equation, because we get a one equation and there is only one variable, we get the value of X. So just try. Okay, we need to find the value of X. So if we have two matrices of order 2 cross 2 and determinant of both matrices are same. That is A1, determinant of A1, B1, C1, D1 is equal to A2, B2, C2, D2. Then we calculate determinant of first and second, and both are equal. So A1 into D1 minus B1 into C1 is equal to A2 into D2 minus B2 into C2. Given that matrix 2, 4, 5, 1 determinant is equal to determinant of 2x, 4, 6x. Then we get, just use the above formula. At first calculate determinant of LHS and then calculate determinant of RHS part. So for the LHS part, we get multiply its diagonal element, that is 2 into 8, 1 minus off diagonal element, that is 4 into 5. And then is equal to determinant of diagonal element, that is 2x into x minus off diagonal element 6 into 4. So when we simplify, we get 2 minus 20 is equal to 2x square minus 24. So just simplify, 2x square is equal to 6. So we get x square is equal to 3. So the value of x is plus minus root under 3. Because when we take square sign on the right hand side, we get square root of 3 plus minus square root of 3. Okay. Because plus root 3 whole square is also 3 and minus root 3 whole square is also 3. So we get two value for x, that is plus root 3 and minus root 3. Now we need to find the value of x for the second, and we know that if two determinants are equal, then determinant of first a1 b1 c1 d1 is a1 into b1 a1 into d1 minus b1 into c1 is equal to a2 into d2 minus b2 into c2. So given that this 2, 3, 4, 5 determinant is equal to determinant of x3 to x5, so apply the above formula, calculate determinant of 2, 3, 4, 5, that is 2 into 5 minus 3 into 4 is equal to x into 5 minus 3 into 2x. So we get 10 minus 12 is equal to 5x minus 6x. We get minus 2 is equal to minus x. Thus, minus minus cancel. We get x is equal to 2. Okay. So by using the determinant, we first convert it into an equation of with x, and then we find the value of x. Okay. So exercise is over. So if you have any doubt, please ask.